The likely performance of a building can be modelled in DesignBuilder by running simulations. The purpose of this tutorial is to show you how to set up a simulation, and during the tutorial I'll look at how the calculations are run, the key parameters involved in setting up the calculation and the simulation output options, which are specified in the simulation options dialog, and finally a strategy for checking your model, which will help eradicate errors prior to running longer simulations or producing final results. Real weather data is used in the simulation to produce detailed information which can be used to assess aspects such as the energy, thermal and comfort performance of a building. Simulations have the following characteristics. Weather data is used from the hourly weather data file. Simulations include solar gain through glazing and consideration of heat conduction and convection between zones of different temperatures. HVAC systems are simulated. And simulations also include a warm-up period to ensure that the starting conditions are correct for aspects such as the temperature of the building's thermal mass. Before setting your calculation options, you should ensure that any zones not required are switched off. For example, you may only want to look at the preliminary results of a few of the key occupied zones during early stage simulations, so switching off zones such as WCs and storerooms will help to speed up the simulations. This is done by navigating to the zone and deselecting the Include Zone in Thermal Calculations option in the Activity tab. Alternatively, you could switch off all blocks and zones at building level and only select the required ones in larger models. The zone names are greyed out in zones which are switched off. Switching off a zone will result in that zone being treated as adiabatic by adjacent zones, so it should only be done if switching off the zone is unlikely to significantly affect the results in the occupied zones. Particular care needs to be taken when switching off zones during calculated natural ventilation simulations to ensure that significant airflow paths are not blocked. This will be covered in more detail in a later tutorial. We first click on the Simulation tab here at the bottom of the screen to view the simulation data. If a simulation has been run already and no changes have been made to the model, the simulation data will be shown, as is the case here. If this is not the case, this Calculation Options dialog will be shown automatically, enabling you to specify the key parameters of the simulation. You can quickly access the dialog from the toolbar, as I did, or from the info panel here on the right, which at the minute is minimized. The simulation options displayed will be those last used, i.e. they're carried forward from the previous simulation. You can, if you wish, give the calculation a name by typing in the text box here. I'll call this Tutorial. A number of simulation period options are available. The start and end dates can be manually specified using these drop-down boxes. Here, for example, I could select the 1st of April to the 30th of April. If I just wanted to analyse that month to look at some aspect of performance, such as the risk of simultaneous heating and cooling during this interseasonal period. DesignBuilder also provides a number of typically used simulation periods here in the info panel, which can be selected by simply left clicking on the period of interest, such as the Summer Design Week. Note how the simulation period from and to, or start and end dates, have now changed. The start and end dates for the various summer and winter options are automatically calculated by the program weather data translator. These typical periods, accessed from the info panel, refer to statistically derived data for the current hourly weather data file, which is set in the Location tab at site level. Weather data is covered in more detail in a later tutorial. The Annual Simulation option sets the simulation to run for the whole year. The Summer Design Week and Summer Typical Week relate to the hottest week and the typical week in summer respectively, and All Summer relates to the summer period from April to September in this weather file. The Winter Design Week and the Typical Winter Week relate to the coldest week and the typical week in winter respectively, and All Winter relates to the winter period from October to March. You can set the output intervals for reporting to any of the four options, and if sub-hourly reporting is selected, you can choose how many times per hour these reports are generated here in the Options tab. You should note that long simulation periods, such as annual, coupled with short output intervals, generate large amounts of data which can significantly slow down simulations or result in failure to load the results after the simulation for medium to large size models. The simulation method shows that Energy Plus was specified as the analysis method in Program Options. You can set the number of times per hour that the calculation engine solves the building thermal network. Increasing the number of time steps generally improves accuracy but slows down simulations and can significantly increase data generation when the sub-hourly reporting interval has been selected. A minimum of 4 time steps per hour are recommended for Energy Plus simulations using simple HVAC, and a minimum of 6 where compact or detailed HVAC is selected. A minimum of 2 time steps per hour is required to access temperature distribution results, so this is selected as the default. Note also that where schedules specify times other than on the hour or on the half hour, then the time steps per hour should be selected accordingly. You can select the most appropriate control radiant fraction from the temperature control drop-down menu. The different options can give very significant differences in results, and using operative temperature control usually leads to higher peak loads in heating and cooling design calculations and higher heating and cooling energy consumption in simulations. A useful discussion on the selection of air or operative temperature control is included in the help file, which can be accessed by typing in the text calculation options here in the help index. The effect of self-shading from the model building surfaces is user-defined and is discussed later in this tutorial. There is the option here to include the shading effect of adjacent buildings in the simulation if these are likely to have a significant impact on the building under analysis. If the option to model reflections and shading of ground reflected solar is chosen, the simulation will include the effects of beam, diffuse and specular reflections from other surfaces on the model building and adjacent buildings. This option also ensures that solar radiation reflected from the ground is shaded by component blocks and other building surfaces. Again, selecting these options could significantly slow down the simulation. They are switched off by default and are normally only selected where there are significant adjacent buildings and or where the building geometry could result in significant reflection between parts of the building, or when shading of ground reflected solar is important. This may require some sensitivity testing using a simplified model to assess the impact of each option on the results. The solar distribution option determines which surfaces provide shading. It should generally be left to the default full exterior option, which assumes that all beam radiation entering a zone falls on the floor and provides a reasonable balance between simulation time and accuracy. This option takes into account the effect of exterior shadowing surfaces and window shading devices. Selecting the minimal shadowing option simplifies and speeds up the simulation, but results in no exterior shadowing except from window and door reveals. The full interior and exterior option is the same as full exterior, except that instead of assuming all transmitted beam solar radiation falls on the floor, the program calculates the amount of beam radiation falling on each surface in the zone, including floor, walls and windows, by projecting the sun's rays through the exterior windows. The full interior and exterior option must be used to account for direct solar and light transmission through interior windows. However, the zone geometry must be convex to successfully use this option, so some geometric compromises may be required to enable you to model internal borrowed light. The more detailed information in the help file should be consulted before using this option. The shadow interval determines how often the position and depth of shadows is recalculated as the sun angle changes through the year, and can be set from 1 to 365 days. The default option of 20-day intervals provides a reasonable compromise between accuracy and the increased simulation time required to frequently recalculate each shadow. The settings under the Advanced header should only be changed by advanced users who understand the implications of changing this data. As always, further information can be found in the comprehensive help file. The Output tab in the Simulation Calculation Options dialog provides options which enable you to control the data generated from simulations. You should only select the options required, as excessive data storage can slow down simulations and prevent large simulations from completing in extreme cases. Selecting the Building and Block Output of Zone Data option causes average and total zone data such as average temperatures, internal gains, fabric transmission losses, etc. to be generated for building and blocks. This option doesn't affect the generation of energy consumption and CO2 data at building level. By default, data for unoccupied zones, i.e. zones which have no occupancy, heating, cooling or mechanical ventilation systems, is excluded from block and building totals and averages. Check this option to include data for unoccupied zones. You can restrict the simulation comfort output to just occupied periods using the drop-down menu. Choosing this means that comfort data is only output during times when the zone is occupied, so daily and monthly comfort statistics become more meaningful. This option should be selected when undertaking summer overheating analysis, which requires the number of occupied hours per year above a specified internal temperature to be reported. You can choose which outputs you want to produce graphical results for under the Graphical Output Options header. The options here are fairly self-explanatory. However, you should note that general comfort-related data outputs such as humidity and air, radiant and operative temperature graphs are produced when the environmental option is selected, so there is normally no need to select this comfort option. The comfort option may however be required when more detailed analysis using specific comfort metrics such as Fanga PMV and the others shown here are required, or when undertaking detailed CFD analysis. Selecting the temperature distribution option enables you to view a graph showing how many hours per year each zone is at, above and below each temperature band. If this is the main purpose of your analysis, for example to produce a summer overheating report showing hours over 28 degrees C for energy code compliance purposes, you can deselect most of the other options and request only temperature distribution and monthly and annual data. This will enable you to produce these results more quickly. Here's an example of an annual temperature distribution graph for the ground floor east office, run with only these options selected. Going back to the calculation options dialog, the other more detailed options such as the internal gains, which enable you to check how the building performs at various times of the day and year, will of course be required to validate your model prior to running the annual simulation. A model checking strategy is discussed later in this tutorial. Standard Energy Plus annual and monthly summary reports can be produced to provide a wide range of summary outputs for the overall building and its constituent components. You can choose to store surface and opening data, but this option should only normally be used for detailed analysis in specific zones or relatively small models, as it generates large amounts of data. The best place to make these selections is on the Options Model Data tab, where specific data for specific surfaces and openings can be selected. Now that I've reviewed all the key calculation options input data, I'll run a quick simulation to generate some zone heat balance data from internal gains and HVAC systems in April. Looking at a 7-day period, we can see that cool interseasonal nighttime temperatures necessitate heating early in the morning, which is often quickly followed by a cooling demand soon after peak occupancy. The graph shows that the deadband set between heating and cooling is sufficient to prevent unstable HVAC system operation and simultaneous heating and cooling, which could have a marked impact on the predicted energy consumption and resulting CO2 emissions of the building. DesignBuilder recommends the following minimum checking procedure for models prior to running large simulations. First, check the model to ensure that data is being correctly inherited from the levels above. This is particularly relevant where data may have been incorrectly hard set, preventing it from inheriting data after design changes. Then run the typical or design summer week simulation and sanity check the hourly graphical results. For example, check that the internal gains profiles appear to be correct, that HVAC systems appear to operate as expected, and that fresh air rates are sufficient. Also check that solar gain and shading operation results appear sensible. Next, run the typical or design winter week simulation, undertaking similar checks. And finally, run an annual temperature distribution simulation, requesting distribution data and check the results for key occupied zones. Once you've completed these checks, you can be confident that your model is behaving as expected, and the results should not be compromised by any major data entry errors. This tutorial has hopefully provided all the information you need to set up and run a simulation in DesignBuilder. I explained the importance of selecting the right outputs to produce the results you require whilst minimizing simulation time, and then provided a strategy for checking your model data prior to running extended simulations or producing final results. In later tutorials, I'll be looking at how you can display, interpret and analyze these outputs.